Chapter 10, Section 10.2. There are three characteristics that will affect a gas. The first is pressure, represented with a P, volume, represented with a V, and temperature, represented with a capital T. Pressure is going to be the force per unit of area. A gas molecule collides against the wall of its container, then it exerts a force. Forces can be measured using what's known as a pressure gauge, such as this one. Atmospheric pressure is going to be the pressure exerted by the atmosphere, where the atmospheric pressure is pushing downward onto the mercury that's in the dish here, and then it's going to push the mercury up the tube, and as it pushes it up the tube, the scale will measure the mercury in a unit of millimeters of mercury. And so it measures how many millimeters of mercury did it rise up the tube. The guy who invented the barometer's name was Torricelli, and so this unit could also be represented with torr. So these are both units of pressure. At sea level, there is 1 atmosphere of pressure. Units of pressure are going to include the following: atmospheres, which is ATM, millimeters of mercury, torr, and kilopascals. There are other units of pressure, such as pascals and pounds per square inch, and you'll be asked to convert between the units. So the conversion factors that you'll need to know, and you're given these on the back of your periodic table, are going to be 1 atmosphere is equal to 760 torr, which is also equal to 760 millimeters of mercury, which equals 101.3 kilopascals. Volume is going to be the amount of space an object takes up. If you look at these examples, you can see that volume number 1 is greater than volume number 2. It's the amount of space the gas takes up. The units of volume that we're going to use for this chapter are milliliters, liters, and centimeters cubed. We'll need to be able to convert between them, so here are your conversion factors. 1 liter equals 1,000 milliliters, which is equal to 1,000 centimeters cubed. Temperature, by definition, is going to be the measure of the kinetic energy on the molecular level. And we use a thermometer in order to measure temperature. And I want you to pay notice to the boiling point and freezing point of water. So we'll look at the boiling point first. Boiling point of water is going to be 100 degrees Celsius, which is equal to 373.15 Kelvin. The freezing point of water in Celsius is going to be 0 degrees Celsius and 273.15 Kelvin. The units of temperature are Celsius, Kelvin, and Fahrenheit, but we're only going to use Celsius and Kelvin in this course. The conversion to get between Kelvin and Celsius is take Celsius, add 273.15, and that'll be what changes it to Kelvin. If we want to solve for Celsius, we'll take Kelvin minus 273.15. If we want to solve for Celsius, then we would take Kelvin and subtract 273.15. STP is standard temperature and standard pressure. And you need to memorize that standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere. If you're asked to give these in a different unit, then you simply convert them. However, I'll tell you that standard temperature could also be 273.15 Kelvin. Standard pressure can also be 760 torr, 760 millimeters of mercury, and 101.3 kilopascals. So we're going to do some conversions for practice. So we'll start with 874 millimeters of mercury is going to equal how many atmospheres? We want to take our millimeters of mercury, put it over 1, times draw a line, bring down millimeters of mercury, and I'm going to go to atmospheres. We know that 1 atmosphere equals 760 millimeters of mercury. 874 divided by 760 will give you 1.15. And so 874 millimeters of mercury equals 1.15 atmospheres. Okay, number 2. I want to change degrees Celsius to Kelvin. So in order to do that, Kelvin is going to equal Celsius, which is 94.3, plus 273.15. 94.3 plus 273.15 is going to give me 367.45 Kelvin. Number 3, we'll take 894 milliliters, put it over 1, bring down milliliters, and we're going to go to liters. 1 liter equals 1,000 milliliters. And so this will give us 0.894 liters. Number 4, we'll take 47 kilopascals, put it over 1, times draw a line, go from kilopascals to atmospheres. 1 atmosphere equals 101.3 kilopascals. We'll take 47 divided by 101.3, and then that gives us 0.46 atmospheres. Number 5 wants to know what is STP in Kelvin and torr. Standard temperature is normally 0 degrees Celsius and 1 atmosphere. However, in Kelvin, standard temperature would be 273.15 Kelvin, and standard pressure would be 760 torr. Number 6, we want to change 0 degrees Celsius to Kelvin. So Kelvin equals 0 degrees Celsius plus 273.15, which just gives us 273.15 Kelvin as our answer. 473.8 torr over 1 times draw a line. We can't go directly from torr to kilopascals, so we're going to go from torr to atmospheres. 1 atmosphere equals 760 torr, and then we'll bring down atmospheres and we'll go to kilopascals. 1 atmosphere equals 101.3 kilopascals. 473.8 divided by 760 times 101.3 will give me 63.15. And that's kilopascals. Number 8, 9.3 atmospheres over 1. Bring down atmospheres. We're going to go from atmospheres to millimeters of mercury, because we know 1 atmosphere equals 760 millimeters of mercury. So 9.3 times 760 gives us 7068 millimeters of mercury. Number 9, 182 Kelvin. We want to change this to degrees Celsius, so we'll take Kelvin and subtract from 273.15, and that's going to equal 182 minus 273.15, and that equals negative 91.15 degrees Celsius. It is possible to have a negative degrees Celsius, but it's not possible to have a negative Kelvin. Number 10, 940 centimeters cubed over 1. We can go straight from centimeters cubed to liter because 1 liter equals 1,000 centimeters cubed. And so that's going to give me 940 divided by 1,000, which equals 0.94 liters. Number 11, 83.4 kilopascals over 1. We know that 1 atmosphere equals 101.3 kilopascals. And then we also know that 1 atmosphere equals 760 torr. Notice I did not go directly from kilopascals to torr. So this will be 83.4 divided by 101.3 times 760, which gives me 626 torr. Last one, 760 millimeters of mercury is going to equal 760 torr because millimeters of mercury and torr are actually the same thing, so they're interchangeable. All right, a couple more. Standard temperature is 0 degrees Celsius, and they want the pressure, standard pressure in kilopascals, which is 101.3 kilopascals. Remember, it normally equals 1 atmosphere, but in kilopascals, it'll be 101.3. Number 14, STP, is standard temperature, 0 degrees, and standard pressure, 1 atmosphere. Number 15, 0.032 liters over 1. Bring down liters. We can go straight to milliliters because we know 1 liter equals 1,000 milliliters. We'll do 0.032 times 1,000, and that gives us 32 milliliters. Finally, 27 milliliters over 1. Bring down milliliters. We can go straight to liters because we know 1 liter equals 1,000 milliliters. And so I'll do 27 divided by 1,000, and that'll give me 0.027.